All right, we should be live. So sweet. I don't know if like anybody's actually, you know, watching or anything, but you know, we're live. So super last minute stream, as I mentioned. Not even sure if I'm not even sure if I'll turn this into a VOD. We'll see. But as I mentioned, we're going to be, or I'm going to be doing a demo. I have some community college group that I occasionally do stuff with. A friend of mine helped start it, so I'm obviously super passionate about people learning about InfoSec. So here I am, trying to help people learn. So tomorrow we're going to be meeting at a local brewery, the same one I do like my talks at occasionally, my Muggle community talks. But tomorrow we're going to be there, and we're going to be talking about attacking web applications and just general pen test process and stuff. Again, these are community college, and there's a couple university folks, but fairly new to not just InfoSec in general, but offensive security and stuff like that. So it's going to be real kind of slow. So tomorrow is going to be about web applications. It's not something that's really covered much, at least from a security perspective in college, at least as far as I can tell. I don't know. I've never been to college, but it seems to be like a subject that's kind of lacking. So we're going to cover that and process and maybe just some neat tricks and whatnot. I see people popping off in chat. Welcome. Thanks for coming. Like I said, this won't be a super formal, just kind of me messing around, playing around with Mutillidae and various web stuff. So if you're new to web stuff or, not, cool, we'll play around today. I'm going to be going to see Captain Marvel a little bit later, so we're just going to do this for a couple hours, but should be a good time. All right, so let's see here. Do I have... Question is, I've been working on so many different computers lately. I'm not sure if I have it installed here. I don't have it installed here. Good, we can walk through the install. So the Mutillidae install is actually really simple. We have to configure the MySQL database just a little bit. We just need to change the root password and set it up to use. I think it's we'll go through the setup, but we have to set it up to use the MySQL native plugin as well. But yeah, so we have to install a couple PHP things and set up the database. So let's get that started. And I don't have this memorized, which I should, because we're going to walk through the installation tomorrow. So I'm going to be taking notes like this whole time because, like I said, I'm basically prepping for what's pretty much a talk tomorrow. So. All right, so we're gonna go. Let's see. So there's Mutillidae is on GitHub. It used to be on like SourceForge or FreshMeat or any of those old package repository sites that are now like bought and package malware and spyware and stuff with all their packages. So I'm glad it's on GitHub. We're gonna go to its GitHub. We're going to clone the repo while we go through the other installation steps. So down here, it's actually got some great videos, like step by step. Like you can check this out. It's like each step has a different video. Since Kali already has essentially LAMP installed, we don't have to really do a lot of this stuff. A lot of this stuff is like, creative for, virtual machine and get Ubuntu installed and install Apache and all this crap. So all we have to do is reset the root password in MySQL and then install Mutillidae on Linux. And the second video kind of walks us through some of the packages we need to install. So again, I'm not going to actually watch these, but I am going to fast forward. I'm going to find the place in the video that actually tells us the specific MySQL commands that we need. So we log in as root. So we're just going to use MySQL to log in as the root user. Oh, first we need to start MySQL, service MySQL start. And again, I'm going to be taking notes. I'm going to be taking notes on my main computer here. So let me get Adam popped up. Actually, let's. I don't have a lot of screen real estate here, but let's take notes. You know, in the main thing. I don't know. I know that people always say that like seeing the process is helpful for people, so that's fine. We can show the whole process. I'll just make my, and we'll so we'll make their Mutillidae notes, or Mutillidae, and we'll cd into that, and we'll vi notes. Okay, so install, and so we need to start MySQL, right? So we're gonna start MySQL, and this will just be starting the MySQL service. So I'm putting it up here so that I can just copy really just the command, or I can copy the entire line. And for those that are relatively new to Linux, you know, you put a octothorpe or hashtag or whatever you want to call this thing in a bash line that's just going to be a comment. So you can copy the whole thing if you want. And then we're going to need to MySQL uroot. And in Kali, there's no root password already currently built in. Oh yeah, I was doing some development. So let me see if I can remember. Cool. Okay. So we need to use MySQL, and this is going to change the database that we're using. Use MySQL. And that's going to set us to use the actual MySQL database where all of the MySQL user accounts and metadata and meta tables are held. So we're going to use that. And then Oop. Okay. So we're going to update user set authentication string equal password. Okay, and what this is doing is, all it's doing is updating the user record. We're setting an authentication string, and this is using a built-in MySQL password function to hash the Mutillidae password. But we only want to update the root user. Okay, so this is laid out pretty much like a normal SQL query that you would normally see like in a web application, but this is a normal like SQL administration kind of query. This will result in that base MySQL hash. So if you're cracking hashes or you dump hashes from a MySQL database, and then you run it through John, it'll be like detected, you know, MySQL, or you know, p MySQL, or some kind of hash like that. That's what this password function is going to make. So we're gonna go ahead and copy this and paste it there. And what we should see is that the rows matched 1 and changed 1. If you don't see the changed 1 here, then that means that the version of MariaDB or MySQL that you're using doesn't use this syntax. You'll run into this quite a bit. It kind of changed in MySQL around like 5.7, 5.8, somewhere in there. And some things use this syntax. Other versions use a different syntax that's like alter user. And so, like I said, I've been doing some web development recently, and since I've been doing that web development on so many different computers, I've been running into a lot of these kind of inconsistencies on how to, on the different syntaxes. So on Kali, it looks like this is the syntax that it wants us to use. And then I believe there's like one more. We have to set a specific plugin. Yeah. And this is just setting the communication plugin that we're using here. So set plugin equal MySQL native password. Where? And this is another place that you can run into trouble here, depending on the different versions that you're using. MySQL native password might not be supported. You might need to use something else. So if you get if you don't get it changed here, then it either messed up or you were already using this. So I already had this set up to use the MySQL native password, so nothing was changed. But you do need this. And if you don't already have it set up to use that plugin and you see a change 0, then something's going on. Either you've got some kind of compatibility issue or something else is happening there. And then the last one that you need to do is flush privileges. And up until very recently, I could never remember how to spell privileges. I always wanted to put like extra E's in there or something. But again, I've been typing this so much recently that I think I finally got it now. And all that's doing is just updating all of the stuff, all the changes that we made here. It's just making sure that it flushes it to the actual database rather than just sitting in memory or sitting there waiting to be saved. Okay, that's basically just saving our changes. Now we've got that set up, we can move on to installing Mutillidae itself. Now the majority of damn it. No ad blocker. No I'm not logged into my account, so ads still happen. Okay, so the majority of this is like cloning it from GitHub, which now it's GitHub and not SourceForge or whatever it's showing here. But there is a little bit of PHP installation here. Now, when you're doing this, you don't actually have to necessarily put in the number. Kali is smart enough to know which version of PHP you're installing, or which version of PHP you have installed. If you had multiple versions of PHP, you'd have to set that up specifically for whatever version you wanted it installed for, whatever version Mutillidae is using. But here we don't need to do that, so we can actually exit. And then we're going to apt install so newer versions of apt, and not even like brand new versions of apt, but for recent versions of apt, you don't have to do apt-get anymore. It's been updated. But so we're going to apt install. I already did an update just before I went live, so I don't need to do the apt update that they did here. But I'll do the apt install PHP curl, and we'll PHP MB string and PHP XML. And yes, looks like I need to do an auto remove. We've got a lot of stuff there. But then we'll do, so apt install PHP curl, PHP MB string, and PHP XML. Now, if you're new to Linux or new to Ubuntu or new to any apt-based package manager, you might not be used to seeing multiple packages being installed from one command line, but that is something that apt supports. You can just put in space delimited, so you just put in package space package space package space, and you can install as many packages as you want in one command. Okay, so that installed, great. If we needed to check the version, we could, but again, I think tomorrow we're all using Kali, so all my notes and install instructions just generally need to be specific to Kali. And this is where it says, okay, go to SourceForge and clone the repo, which we already did. And then what will happen, so we need to do we'll do like a service. Apache 2, I believe, is the service name start. We'll confirm here. Service Apache. We can just tab and it'll show us, but we'll Apache 2 and then start. Cool, and that should start. We should be able to see grep Apache. And yeah, we see Apache running as www data, which is what we want. And if we go to 27001, /Mutillidae. Well, that's interesting. Let's see here. So it's not nothing. Is my Foxy proxy getting in the way? No, because I'm not using localhost, I'm using 127.0.0.1. Let's get burp running, and then we'll at least we'll be able to see like what the requests look like, what's going back and forth here. So tomorrow we will be talking about burp and, you know, intercept proxies and proxies in general, but mostly intercept proxies for the purpose of attacking. So we'll have this up, turn intercept off and HTTP history on, and we'll refresh. Oh, we're not using localhost. 404, this is 404 not found. So all we're doing right now is we're just using this as for the history, right? So, okay, so we do the get for Mutillidae. Oh, we get a status 500. Internal server error. That's interesting. Varlog Apache, yeah. And we'll check out the error logs. It's getting some XML issue. Oh, wait. What is happening here? Did we not finish that video like we should have? Is there like more to it? Oh, no, not the ads. Why ads? Why? Why do you exist? You're the worst. This is why I don't monetize any of my videos. They're just super obnoxious. Yeah, see, we should be getting the database. Everything's already the newest. Groovy. Just do this apt.auto-remove real quick. Just to stop seeing all that extra crap. Oh, did I spell it wrong? No. It is completing the URL for me. Varlog Apache. That's error. 82909. Yep, that's the one. Let's see here. Got error called to undefined function simple XML load file. Oh, let's do some Googling. Welcome to Hacking 101. Something doesn't work, Google it. It seems to think that we don't have... So let's do PHP version, doing 7.3. And when we say apt install PHP XML, what version is it installing? Yeah, that's the version that's installed. It's probably like the fact that I just updated, like biting me in the ass. Then again, I got this running on my laptop, and my laptop's running like the newest version of Kali, like the, you know, just released a couple days ago or a week ago VM. So that's the, oh, 301, just to... Hey, Ryan, let's see, Ryan Bitsky. Hopefully I didn't murder that. Welcome to the Twitch channel, Twitch stream. What was the... Simple XML. What? It is simple XML load file. That's what it's saying that it's failing on. But it's not in... Oh, because it's not actually in the, it's right here. And it says that this function doesn't exist. God, it feels like my microphone's like so far away. Hold on, I need to fix my microphone real quick. All right, that's better. I haven't really streamed very much since I got this new desk, and the microphone was just so far away. All right, so we got the simple XML load file, and I mean, all these blog posts are coming from like 2017, which feels like a problem that I should be running into. Let's do this. Let's let's purge PHP XML. Let's just reinstall it real quick. I mean, it seems silly, but while I'm on stream, I'd just rather like get it up and running. We're gonna do the 7.3 XML. Wait, it's already installed. Apt purge PHP 3. Maybe, did it have 2 different libraries installed? That could have definitely been a problem. Okay, so it's going to install, I guess, both? Like, I would imagine that one is just a reference to another. And I guess the next step is just to go into the actual, like, PHP config files and make sure that it's all pointing to the right place and whatnot. Nope, still failing. Still the same problem. I have several versions of PHP running. So let's see what version Apache is running. So there's PHP test, PHP info. I believe it's just like PHP, yeah. So we're going to go to vi test.php. I'm going to check out which version. Aha! That's probably the problem. Okay, so we're going to apt install PHP 7.0 -XML. Let's see here. So apt search PHP XML. I don't know if apt search actually So we want it to use 7.3. Let's see. Force PHP version. Nope, not in cPanel. I know how to install them. Oh, update alternatives. We'll see if this works. See, that's what I don't understand, is like when I just run PHP, yeah, when I just run PHP, it uses the newer one. but like Apache, so it's got to be somewhere in the Apache configs, right? Ah, okay. So if let's see, Apache conft. See. Okay, where the hell is the... So what we're doing here is we're just we're using find to find all of the PHP inis in root. And there's several, of course. So... what is this? A2 dis... What? Okay. All right, so now it's using 7.3. And now it works. All right. Cool. Okay, so let's see here. So in our notes, troubleshoot. We're gonna, okay, troubleshoot XML function not found 500 error. So was it A2 dismod PHP 7.0 A2 nmod PHP 7.3. PHP plugin versions. Probably 7.3 if they just recently updated. Now I think, okay, so let's explain kind of what happened here. So as I mentioned, my my laptop had the newest version of Kali, like the VM that you can just now download. My guess is this is an older Kali that I've just been like dist upgrading over and over again. And so it's probably got several, it seems to have several versions of PHP, probably just that it collected throughout time. Because of that, it's been using this older version of PHP for a while, and it never got updated. And so when I installed these plugins, it installed for the newest version, because duh. I never switched over the PHP version that Apache is using. Whereas on my laptop, all it ever had was the newest version of PHP, and so it didn't have that version mismatch is what I'm guessing happened here. But this is good. This is why I do this prep stuff ahead of time, and a lot of people don't usually see this. I don't usually do this kind of stuff, but you would be amazed at the amount of prep that speakers and instructors and various people put into just these kind of one-off, like tomorrow's going to be super casual. It's going to be at a brewery. We're going to have some beer. We're going to hack some stuff. But, hours and hours and hours go into making sure that those things run smoothly, right? Anyways, so cool. I'm glad that I found this now. So we can do PHP PHP info page. Just do PHP info, right? Var dev HTML, Mutillidae, cat test it, just to make sure. Yeah, okay. Okay, cool. So all of that is done. Now, all that needs to be done now, hopefully, database server appears to be offline. What? Failed to connect to database. Oh, probably just because it's not set up. Let's see. Let's find out. So we can click that. No errors were detected. Super cool. So as long as we did our database setup correctly, we will see this database error page, unable to connect to the database, and then we see that link. Click link to setup DB, and as long as there's no errors, then you're good. Okay, that means that we set up the database correctly. If there are errors, then we need to read the errors, figure out like what went wrong, go back and reset up the database. Likely what happened, and this is why I next time this happens, I'm sorry, I got distracted by chat. That's why earlier I said pay attention to this, like when it said, rows matched, rows changed. If you had rows change 0 and there was some problem that you had changing the password, that's going to be likely the problem that you run into if there's errors here. And here's Mutillidae. Sweet, we made it. We made it. Good job, team. Okay, we probably don't need all of these. This is why I have a 4K monitor sitting right here where like all of my streaming displays are. But I have to stream at 1080p because, that is life. But I miss having all that screen real estate. So Batresh points out that apt-get auto-clean, apt-get clean, apt-get auto-remove should fix that next time. I did do an apt-get auto-remove. Let's see if apt-get apt-clean. Let's do, God, what is the dry run? Apt-clean h. Erase downloaded archived files. Okay. Yeah, that's just going to download the that's going to get rid of the archived files. That's not going to get rid of like actual installed files. The auto remove might have worked, though I did do an auto remove. It's possible that auto remove didn't work because Apache was still using it. So let's do an apt auto remove right now. And see if it, nope. Yeah, so auto remove wouldn't have worked. It's not marked for auto remove. So we actually either have to purge it especially, or we have to change what Apache is looking at. Good call out. I have seen apt auto clean and apt clean work really well, especially when you start to get close to filling up your hard disk. I ended up changing mine. I think default Kali comes with like 20 gigs or like 30 gigs or something, which clearly is not enough for us. But anyways, yeah. So good call out. I do appreciate the input. I'm not sure it would have fixed it for us though, just because again, Apache was using that version. Okay, so let's start getting into some Mutillidae stuff now that we're 40 minutes in it. How long has the stream been going on? So long. Feels like forever, right? I don't even know anymore. Does any of this tell me? All of these status windows? Nothing tells me how long I've been streaming for? Cool. It looks like I started right around 8:10, so it's been 40 minutes it took me to get this up and running. Sweet. Sorry, Ryan, I don't have any bots in the Twitch channel. But anyways. Okay, cool. So let's actually do some Mutillidae stuff. So you'll notice in we've got the 2017 OWASP top 10. There's also the 2013 for the stuff that's, still hanging around. But let's just kind of go through some of these things. Now, tomorrow, again, we are... this is for, again, a college group. And they are, clearly intelligent people and probably know more about computer science than I do because, a lot of them are computer science students and I am not. But web is something that I don't know how much of that is taught. So we're going to be looking at probably SQL injection, a bit of cross-site scripting, command injection we'll probably do, and a little bit of maybe file upload. XXE would be kind of cool, but it's a little abstract for like the first time out, so we might not do XXE tomorrow, maybe like next month. The plan is to make this like a monthly thing for them. So maybe like next month we'll do like XXE. So let's see. So let's plan this out. So we're going to do like SQLi. We're going to do cross-site scripting, command injection for sure. I mean, we're going to do burp, but that's just going to kind of be, incidental to all of the other conversations that we have. And then maybe file upload. We'll see. We're only going for 2 hours tomorrow, so I don't know that we'll be able to hit this many subjects, but like these are the big ones. So, and probably like the most straightforward. Oh, no. What am I talking about? We need to do LFI. These are probably the big ones, right? So, let's start off with SQL injection. So we'll go to and this is what I love about Mutillidae. If you haven't seen Mutillidae before, it's all broken out to the OWASP top 10, right? And underneath each OWASP top 10, so for instance, we've got injection SQL, or injection's the big one, right? So it broke it out between SQL and other things. So there's command injection and, XXE and stuff like this. It breaks it out by each one. So underneath SQL injection, it has like a bunch of different types of SQL injection, and all these vulnerabilities are just like ready to go, right? So I love using these for demonstrations because I don't have to code up an entire web app and like rewrite the vulnerabilities and all this stuff. I can just install this and go. So we're gonna look at the extract data first, and so we're greeted with a login screen, and this login screen has a couple different things. We can probably bypass authentication, or we can do some sort of what it said is that it's ready for some data dump, right? So let's clear our history so that we're starting fresh here. I don't have all those 500 errors there. So if we just try and like log in. And I'll just log in rook, and it says a couple interesting things, right? So we get an authentication error that says bad username or password, which is good. It's not telling us that the username. It's not telling us which is bad, right? So we can't necessarily use that for username enumeration or anything like that. It's not necessarily, and we don't know yet, but it's not necessarily giving us like an indication on that something was true. So like a binary inference, and we'll get into that a little bit later, but a binary inference doesn't seem to be possible here. So it says, but what it does do is it gives us a little bit of an indication here. It says results for Rook, 0 records found. Now this is doing two things, and this is kind of scary, right? First of all, it appears to be bouncing or reflecting some of our information back at us, some of our input back at us. Okay, and then it's also saying 0 records found. So it seems to be trying to log us in and doing a database search. So let's change that. It's already got all kinds of crazy stuff in here, but let's input some alternative information here. So we're going to put 1 in here, and we're going to put 2 in here. Just so when we get this reflection back, we'll know which field is reflecting back at us. We assume it's name, but it could be password for some reason. So we'll view account details, and we're getting a reflection back from 1. Okay. Cool. So it appears as though if we just do like one view account details. Okay, so we can search just for one. If we do admin or I'm just kind of guessing here. Okay. So we don't necessarily know. But if we do like what if we do I'm just kind of skipping ahead here. So we're going to do some cross-site scripting first. Let's see if it, since it's reflecting our input back at us, let's see if it'll let us inject JavaScript here. And it totally does. So let's take a look in the code on what just happened. So we have a GET request, and this seems to be doing GET instead of POST, which is a little bit weird for a login page, but not unheard of, I guess. But we put in some information here, and it makes a GET request to itself. And we look and we see that the username is a GET parameter, and then the password is also a GET parameter. And the difference, if you get confused, you know, you've heard of GET and you've heard of POST and you've heard of put and update and delete and move and all these crazy different types of HTTP methods, right? The two most popular, I think, by far, at least in the common internet, not necessarily talking about REST APIs or anything like that, but the common internet, the two most common HTTP methods are POST and GET. And the only thing you need to really remember about them, for the most part, is that GET requests put their parameters in the URL, like you see here. You know, so you do a question mark, and then you kind of put a parameter equals blah, and then you can chain your parameters with the ampersand. Okay, a POST puts the parameters in the body of the request. Okay, so that's the primary difference between the two. Now, when you start talking about REST APIs and all this other stuff, then GET and POST and put and all these other things have very specific meanings according to like how REST APIs are supposed to work. But normal internet, GET, the parameters are in the URL, and POST, the parameters are in the body. So we see this request come through, and we've got the page is userinfo.php. So that's the page that we're looking at. The username we submitted is in here, and this is going to be important. So the username we submitted, if you remember, if you look at this, will it auto decode here? No. This is URL encoded, but if you remember what this looked like, ASCII to hex. If you remember what this looked like, this is what we put in here, and we did script alert 1 end script. And that's just like a really brief JavaScript that pops up an alert box, sort of like what we saw here, right? So if we do this again, just for S's and G's, we see that an alert box pops up, and that's just JavaScript doing that. Now, why does that work? So if we look at the response, here, we see a bunch of PHP code because Mutillidae is not clean. I mean, it is very clean, but there's just a lot of code here. I try and find where our actual input is. We can actually do a search for a script. Oh, there's a lot of it. Let's do alert 1. Okay. We come in here and we see that the results for, and we see a quote symbol. Here is our input. Okay, if we look at an earlier one, and we look for, it's just one, right? Or let's do an earlier one. Let's find the one where I did rook. Here. If we do a search for rook, we'll see that in the same block where it displays our output, it just displays our output and it puts rook here. Okay, so very commonly when we talk about injection attacks, and specifically cross-site scripting or XSS injection attacks, the way we discover these things is that some form of our input is being displayed, reflected to the user. Okay, and what that allows us to do is that we can put in JavaScript or some sort of web language into the code of the web page that some other user is going to look at. There are three main types of cross-site scripting, but we're going to talk about two primarily right now. And what the thing that you need to understand about cross-site scripting is that it really is not an attack against the site. Okay, cross-site scripting is a weird name for this vulnerability, a weird name for this attack. What you're doing is you're attacking someone's browser. Okay, it is a client-side attack. And the easy way to remember this is that JavaScript is a client-side language. Okay, it is not ran on the server; it's ran on the actual client itself. So it's what you can think of it as is a reflected script injection attack. Okay, so we're bouncing a script off of the website that we're going to be attacked, or we're bouncing a script off of a website so that we can deliver it to our target's web browser. So as we see that our input here, we used rook as our username input, is being reflected back to us. If we come down here, we see that without being filtered, without being escaped in any way, our script input is being reflected back to the user as well. So we can actually get JavaScript to run inside of someone else's browser. And what's really handy about this, handy from an attacker point of view, right? What's really handy about this is since it's a GET request instead of a POST request, we can actually send this URL to somebody, and when they load the URL, it will run our JavaScript because the JavaScript is embedded in the URL for us. So the next type of cross-site scripting, I mentioned that there's two that we're going to be talking about specifically. The next type that we can talk about is stored cross-site scripting. And that's generally when you have the ability to insert content into a website, either with either as an ad network, so you insert some sort of ad, as like, does anybody remember website guest books? Remember like the GeoCities days and stuff like that, where like everybody, not many people on the internet had web pages back then, and there wasn't really a thing like any social network, back then. There was no MySpace or Facebook or Friendster or any of that stuff back then. And so you would come to this person's GeoCities page that had this ridiculously long URL, and they would have a guest book because it was really cool to us back then that, people across the earth were connecting with us like connecting with us from all over the globe. This was a new novel concept to us, right? And the you can think of guest books sort of like comment fields now, except a lot less toxic. But anyways, so we had guest books back then. Nowadays, you can think of stored like like a comment field, or if there's some sort of like content injection that you can do, some vulnerability you can do where you can inject content into a web page. This is an example of stored cross-site scripting. And all that is that you essentially do the same thing we did here, where we put in the script alert 1 tag in there, but we put it into a comment field instead. Now, what I would like to say is modern cross-site scripting that actually gets executed in the wild is much more complex than that. There's a lot of filter bypassing that you need to do, and there's more commonly than just what I showed here. More common these days in the wild is something called DOM-based cross-site scripting. But again, we're starting out basic here. The people that I'm talking to tomorrow are just starting out their offensive journey, right? They're just they've been learning about defensive InfoSec and all this stuff in school, and they're just starting to kind of peek at the other side of the curtain here. So we're not going to get into too many really complex topics today. So this is a interesting cross-site scripting vector that's not even in the cross-site scripting. It might be in the cross-site scripting page here, but yeah, there's all kinds of different places that we can do cross-site scripting. It's very pervasive. Okay. The other thing that the thing we actually came here to talk about is, SQL injection. So let's start talking about SQL injection. So you'll see in my history, you'll start to see some weird things pop up like this, single quote or 1 equals 1 kind of stuff, and it's like, what the heck is that? So we're going to put in a single quote here, and we're going to see if we get an error, and we do. And the reason that we get this error is because we are messing up the SQL statement on the back end. So let's talk about SQL for a minute. We're going to open up a new browser here, and we're going to, Okay. Show databases, and we're going to use Mutillidae. Okay, so SQL is a type of database, and SQL stands for Structured Query Language, and what that means is that there is a specific type of query language that we use. Now, in a database, there are many databases inside MySQL, or in this case, MariaDB, which is a open source fork of MySQL. But inside each database, there are a series of tables, okay? And Mutillidae has a bunch of different tables. The way that you query those, and you can see kind of an example of a query here, the way that you query those is with this structured query language. So we select something, okay? So we're going to select everything, so all of the columns from accounts. Okay, so we're saying the way it works here is we could just do this, right? And so what we're saying is we want to select every column from the table, whatever table we're talking about, right? So we have table accounts. And if we do that, then we get all of the tables here. And you can see all their passwords and everything. It's very clear to you now, as you look at this, that getting access to the actual raw database is very useful. This is protected information. You have to store useful information in here, perhaps sensitive information in here to be used. So what will often happen is that web applications will only give you certain information. So what they'll do instead is something like this. They'll select username, comma, first name, comma, last name from accounts. And so this would be a more realistic query from a web page. But what's even more realistic, and like I said, this is more realistic. What's more realistic than this, and this is where things start to get a little more complex, is that we don't necessarily want to display everything, right? We only want to display one or two. We only want to. Let's see if I can find a. Do we have... See, this is weird. Like, this is a weird page. What they should have is instead of this being a login, it's like a find user information, right? But we want to specify, we want to get very specific account. So instead we'll say we want to select these three fields, so these three columns from the accounts table, but we will only want to do it where username, or let's do first name equals something. Okay. And so what's happening here is when we type in a name in this name field, our input is being injected into this field. So you can look at it like this. So there's like a variable here where we're getting our input, where we're injecting our input. So when we inject our input, let's say we put in, it's not doing by username because we tried admin earlier. Let's do system. Still not doing that search. That's weird. But we can do first name system here. And it'll only show us this information. So what happens if instead we put a quote? So remember, we put in a single quote here, and it just vomited all this information at us, right? This is an error that we're getting. And so if we do a single quote in here, we get an error. Why are we getting an error? Much like any other programming language, the quotes matter. And so what's happening here is this quote that we put in here is closing the first name entry quote. Then we have a third quote that's quoting out the semicolon, which tells it that it's the end of a query. So now it's like, well, we haven't gotten to the end of a query. We need to close out that quote. Okay, so we closed out that quote. Now there's only like, we have quote, semicolon, quote. So that semicolon's being quoted. We don't have an end of a semicolon, so we got to put our own semicolon. And that closes out the query. Now we didn't get anything back from that. What happens if we add another quote? So let's do 2 quotes in here. We don't get anything, right? And as we see, if we put in 2 quotes here, we don't get anything. This is indicative of SQL injection. This is one of the ways that we discover the ability to do SQL injection. So what happens here is if we do one single quote and we get an error, it's clear that we're able to inject into the SQL statement. If we don't get an error, then it's less clear, right? But if we put in 2 quotes here and we also don't get an error, it's possible, though not 100%, but it's possible that we're able to inject into SQL. So what does all this mean? So now that we have the ability to break out, as you saw, we broke out of this input, we can actually start changing what information we get back. Okay, so we can do something like, as you saw before, I did this single quote or 1 equals 1. Okay, so we can dissect sort of what's going on here. So we this is what our input looks like. Okay, so it's just that. It's just the highlighted part. As you saw, that's what our input looks like. Okay, so let's look at the SQL, what it's actually doing on the back end. We're closing out that first name, and then we're saying, or the string of 1 equals the string of 1. Now, why are we saying that? Well, as we saw, having these unbalanced quotes cause some sort of error. So what we have to do is we have to balance those quotes. So what we can do is we can add our own quotes here and take advantage of that last quote. That last quote's already going to be there. It's going to be there whenever. So we just add our own quotes. So we say, hey, we'll quote 1, and that makes it a string of 1 instead of an integer of 1, equal to open quote 1, and then we use that last quote to finish our quote. And then so it's saying, or the string of 1 equals string of 1. And look what happens when we do this. We get all of the output. And if we do that again here, is it the... Yeah, okay, it's the password that's actually vulnerable to it. If we do that here, we can see that it gives us all of the information. Now, that is interesting to us, right? So if we just put an A here for no reason, and we put a single quote here, we get an error as well. So it looks like both input fields are vulnerable to cross-site scripting. I'm sorry, SQL injection. Brain is a little fuzzy. Okay, so you can see how on the SQL end, this is working. Okay, on the SQL end, we can actually see when we interact with the database directly what our SQL injection payloads are actually doing and how they affect the database itself. There is, if the web application is passing our input directly to the database and the database is processing it as SQL, there is zero difference between what we can do directly on the database and what we can do in the application. Okay, we're just modifying whatever SQL query is already in place. So we can do fun stuff, right? So we can do, let's see here, show tables again, just check out what we've got. And we'll select star from credit cards. Okay, I want everyone to be aware of this before I click go. This is not a real database full of credit cards. These are not real credit cards. Don't freak out that I'm dumping a database full of credit cards on the internet. This is not illegal hacking. This is a sample database. This is a built to be vulnerable web application. I will say it again. These are not real credit cards. Okay, so we'll check this out. Okay, here's something cool. There's this thing called union select. Okay, so we're going to get back here and we have our original query, right? And as we recall, our input goes here. Now, there's a few things we need to understand. The way this is being printed out is that this is going to return 3 fields. If we mess with the output, if we mess with the query, we need to make sure that whatever we're doing is going to output in 3 fields. So what we can do is we can, in our input, we can hit the single quote to break out a first name, and then we can do something called a union select. And we will select CC number, let's see here. What are we doing? CC number 1, 1, or the strings of 1, from, and the name was credit cards. Okay, let's talk about what this is doing. Now, remember, everything that I'm highlighting right now is our input. Everything that is not highlighted is what was already there. Okay, so it's assuming that we're just going to input something into the into the first name field. We single quote to get out of that first name field. Then we use something called a union select, and we actually start grabbing different information from other places. Okay, so what we need to do, as I mentioned, the number of fields that we get need to match the number of fields that we're asking for, or that the original query is asking for. So the original query is asking for username, first name, last name, right? So we need to match the number of fields. We also need to match the data type. Okay, so these all need to be strings. Now, I'm not sure if this is strings or if this is an integer or long or something, but let's hope it's a string. And or varchar is what the actual data type would be, but we'll see. So we're going to union select, and we're going to say we want the credit card number and then just some junk data from credit cards. So this part of the query should look familiar to you, right? There's no difference between this select and this select, except we're using union to combine the 2 select statements. Okay. Now let's talk about this bit. It is not always possible to balance the quotes. Okay, we can't always do that. So sometimes what we have to do is we actually use a semicolon to end the query. So this whole query, we use a semicolon to end that query, and then we use a octothorpe or hashtag or pound sign or whatever you want to call it. Or in some SQL instances, it's -- instead of the octothorpe, to comment the rest of the query. And all that's doing is saying, hey, all that stuff after this, ignore it. Okay, and that's how we balance the quotes. That's how we deal with the fact that there's an extra quote there left over by the original query. So if we hit enter, so we're seeing something interesting here, right? We don't actually get any information back, excuse me, from first name, because we're just saying, hey, we want you to display the username, first name, and last name from the table accounts where the first name equals blank. Well, none of the first names equal blank, so it doesn't return anything. But we also want to tack on this extra select statement, and we want the credit card number, and then we'll just fill in ones to the other fields from the credit cards table. So all it's doing is saying, okay, cool. Well, there's no names that go in here, so there's nothing there. But we're going to give you all the credit card numbers from the table itself. Okay, so that's what this SQL injection is doing. And union select is very, very, very powerful, because even if your SQL query is not accessing sensitive data, right? It's not accessing credit card numbers. It's not accessing passwords. Maybe it's just a directory search, right? It's just like, hey, enter a name and we'll give you the email address and phone number for it, right? Like a normal employee database access directory. So even if it's only doing benign data, you can possibly use union statements, union selects, and other types of union statements to access data, modify data that query wasn't originally meant to access. Okay, so very, very powerful, very, very dangerous stuff. Very, very useful. Now, you don't necessarily need to do the ones here. You can, we can change these ones. I mean, CCV, isn't it CVV, not CCV? Maybe they did that on purpose. But we can do CCV and we can do expiration, because those are needed, right, to actually run a credit card purchase. So we can put those in there as well, and we actually get all of that information. Now, it doesn't matter, like, if we wanted to, like, we could put, let's see, what's one of the names? If we put, like Ed in there, we can put Ed in here, and it'll return Ed's username, first name, and last name, but it'll still tack on our union query stuff on top of it. Okay, so that is in a nutshell. Now, there is a lot more to SQL injection. There is like blind SQL injection. There's this really neat thing that's a subset of blind called binary inference, blind binary inference SQL injection. There's like timing-based blind. There's all these different kind of blind. And that is much more common in the wild because there's tools out there that make exploiting this stuff trivial. Okay, it's very, 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 very easy to attack this sort of thing with a tool, especially when it's this poorly defended. So let's show how we do that. We'll put in not invalid things, and we'll go here into our trusty burp suite, and all this is really just a history of our requests and responses, right? So we're going to right click this. We're going to save item, and we're going to call this I'm lost in a GUI. Mutillidae, and we're going to call this SQLi.request. And we have this nifty tool called SQLMap. And we're just going to read in the SQLi. Nope. Oh, I'm in the wrong Mutillidae. We're going to SQLMap, and we're going to read in the SQLi.request file. Now, when we run this, it's just going to take the request that we already had. So it takes the full request information that we had, and it's going to start analyzing it, trying to figure out what sort of database is in the backend. And it says that it thinks it's MySQL. Now, again, we're using MariaDB, or MariaDB, depending. But all that is just a fork, an open source fork of MySQL. And that happened when Oracle bought MySQL. But yes, it's MySQL. So we can skip all of the remaining tests. We don't necessarily need to extend the level and risk. And again, this is a basic walkthrough, so we're not going to talk about like the advanced uses of SQLMap or anything. I just want to show how easy it is to use SQLMap. Now, once it understands what the database is going to be, it's going to start doing various different types of SQL injection attacks against the parameters that it has access to to see if they're vulnerable to SQL injection. So it sees that username is vulnerable to SQL injection. Yeah, we want to check other stuff. It sees that password is vulnerable to SQL injection, and no, we don't want to test anything else. So which one do we want to attack? Well, we were getting more interesting information from password, so we're going to use password. Oh, and it said, cool, you can do funky stuff to password. Now, if we wanted to, we can just dump the database, and we say, and we do that super intuitively, -- dump. We just add it to the end of the command. And we want to use the password, so we'll use 0. And it goes through and it literally just starts dumping every database, every table that is in that database. So we can go through and see all of the different tables. There's the user table. Here's the credit card table. We can see that there's a blogs table that we can see all the blog posts. So we can dump the entire database in this one simple command. That's a little terrifying, but at the same time, SQLMap really did us a favor because it made it so easy to detect, so easy to detect SQL injection attacks that a lot of the really simple, a lot of the really just basic BS SQL injections that we just did, that I just walked you through, have been eradicated from the internet. Now, they're not all gone. I still run into them occasionally, but they're generally pretty well understood and disappeared. So that's where this blind SQL injection comes from. What blind SQL injection is if we didn't get any error, right? If we did this, if we did this, and we didn't get a MySQL error, right? We just got, no user could be found kind of thing. That doesn't necessarily mean that it's not vulnerable to SQL injection. It just means that we're not seeing the result. They're just hiding the errors from us. So we have to come up with innovative ways to test for and do SQL injection in ways that we can understand what's going on. Now, one of the ways that I talked about that was I mentioned 2 types. Binary inference and timing based. So what we can do if we weren't getting this data back is that we could do SQL statements with like time statements in them. So like wait or sleep statements in them that says, do this, here's my input, but also like sleep for 5 seconds. And if it takes this web server 5 seconds to get back to us, one of 2 things happen. One, it's processing our SQL injection or our SQL statements. Or 2, that web server is getting hammered. And it would be a interesting coincidence if it was getting hammered in just the right way that it took exactly or very near 5 seconds to get back to us. So it's an indication, and we can do 10 seconds or 3 seconds or whatever we want, right? It doesn't have to be 5 seconds. But if it waits that 5 seconds before it gives us our response, it's a very good indication that it's processing our SQL. And then we can do statements like, if this data is true, then sleep 5 seconds. And then we know that, okay, whatever SQL statement we just put in is true. So we can start inferring different things. We can start inferring like the contents of the database that way. So that's kind of a rough, very brief overview of kind of what blind SQL injection is and like how that works, at least in one of the ways. All right, sorry, just a little bit of chatting going on. Okay, so we did, we did SQL injection, we did cross-site scripting. We can talk a little bit about LFI. LFI is super fun because like PHP just loves LFI, I think. Man, it's so easy to program LFI into your web pages. It's kind of stupid. So what's happening with this site? I alluded to it earlier, but I want to point this out, is we have this index ? page equals. Now this is a GET request, and we're using these variables for various things. The username is clearly the username and the password that we're trying to authenticate with, right? The info submit button is performing a certain action, fine, whatever. But at its base, at the very base of like how this web page is working, is that basically there is a wrapper PHP file that has like a lot of the standard information in it, but it uses this page equals to figure out what other information it should be pulling in, what other let's see, what other like page, what page code it should be pulling in. So you can use this page equals user info .php, and it'll say, oh, okay, I need to include the user info page, and so it includes that code. What is happening on that back end? Let's take a look at this. There was a question, so let me try and address the question while we do this. LVI index.php. Maybe we do get page. What? Is it getting the include from somewhere else? That's lame. Okay, what was the question? We had a question here. With blind testing, how would you actually get to the data you were looking for at the end? From Hadian and Twitch. Great question. So with blind, you have to infer. What's going on. So it's sort of like kind of what I said. Like if you say, okay, select this information where first name equals blah from this table, and sleep for 5 seconds. The way and works is it'll only work if it's true, right? If the previous one's true. So if it sleeps for 5 seconds or however long you put that sleep time for, you know that that whatever you said previous was true. Okay, and this is a high level kind of glossing over it, where this isn't like a deep dive SQL injection stream, but you basically make statements that are guesses, and based on the behavior, whether it sleeps, or you can bake in like a ping or a DNS, like do this and resolve this domain name, and it's obviously a domain that you control, so you can see the domain requests come in. If you see that behavior that you and on top of it, then you know that whatever you just said was true. There's another one that's like it's called blind binary inference, and it kind of works the same way. So, so let's just say A and A. So if imagine this web application is not behaving this way, but if this web application was behaving so that if you put in a bad username, it says bad username. But if you put in a good username but a bad password, it just said bad password. That gives us a true false statement, right? If we put in a good username, the error that we get is bad password. If we put in a bad username, the error that we get is bad username. So that gives us a true. Okay, if we put in a valid username, we can use that as our true statement, and then we can start using that to infer bits about the data. So we can say, hey, database, and again, this is kind of high level. This isn't what the query would look like, but we can say, hey, database, does the first letter of the first table in the Mutillidae database start with an M, or is it greater than M? Because you can actually convert ASCII characters into numbers. So you say, is the first character in the first table, of the table name in the Mutillidae database, is it greater than M? And if it gives you a true statement, then we know that whatever that first letter is of the name of that first table is like somewhere in the alphabet above M. Okay, and then we can go, okay, is it above Q? And then it gives us a true, and we're like, okay, it's somewhere in the alphabet above Q, and we can use that to start narrowing down. Okay, the name of the table is like S or something, right? And we're like, okay, S is the first letter of the, and then we say, okay, the second letter of the first table. And as you can guess, this is very, very repetitive, boring, tedious kind of work. And you can automate it. There are scripts out there, there are tools out there. Hell, SQLMap will do it for you if you know how to use SQLMap correctly. But that is how, again, at a very high level, that's how you kind of pull data out with blind SQL injection. Hopefully that answered your question. Yeah, you're never actually able to see the data. That's why the question was, so you're never actually able to see the data, so you have to test everything. And the answer is yes. Blind is very descriptive in this case because you actually never see the output from the database. You're inferring like everything. So you're inferring the information that's coming to you based on the behaviors that you see, whether it's the time-based like wait or some sort of like DNS callback that you're observing, or if the application itself is giving you that true-false information. It's all inference. Okay, cool. So moving on. Let's see if we can find these include. Damn it. Okay. So let's see, constants, excuse me, remote file handler, log handler. Where is it actually pulling the information from? I would like to show you the actual include because that gets it like across really easily. But we can, I think this is enough to kind of show you. So, all right, let's do this. So if we grep, let's see. It's page, right? Page. Aw, come on. It's like a pain in the ass because I think the dollar sign is gonna cause problems with this. Nope. Okay, cool. Nope, it definitely does. Damn it. So if we do grep this, and then we grep that output for page. Ah, here we go. Okay, cool. So if we less this guy. What? It's like literally telling me that it's right here. Where? Data arbitrary file inclusion.php. That's like, it's exactly what I want. Nope. Oh, it's just in here. It's an arbitrary file inclusion. Huh. Yeah, that's funny. Okay. Should have known from the name. So or is this just like... Oh, come on. Why? Do. So this page just explains why it's bad and like what it is. Damn it. Okay. Well, let's. I guess I wish I could just show this to you, but it takes a while. It'd take a while for me to actually find what's going on here. But what you can see at least in here is, okay, we see this include once, okay, and what this is doing is it's including a file, okay, it's including a file from the server, from the actual file system itself. Now, what this statement is doing correctly is that it's requiring you to be in the root, right? It's trying to actually put you in the root itself, the root of the server, not the root of the root of the web server, not the root of the actual system. Okay, so it's saying I need you to actually go to the root of the web server and go into the includes directory and process commands.php. If it is not sufficiently sanitizing the user input, and this is a common problem for all of these vulnerabilities that we've discussed so far. The cross-site scripting is kind of sanitization, like input sanitization. SQL injection is definitely a problem when you're trusting user input, and local file include is also a problem where you trust user input. But instead of saying, hey, we want this page, right? We can actually tell it like, look, you want us to be in this directory? We actually want to back out of that directory. And so we use the Linux or even Windows, we use the syntax of, we actually want you to go into the parent, and we want you to go into that parent, and then we, the parent of 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 the parent. And if we do that enough times, once you get to the root of the file system, it'll never keep going up, right? It'll just stay there at the root of the file system. So you'll see people do this like 20 times or whatever, because you don't know what file we're in. We don't know what directory structure we're in. So we'll just do it a bunch of times until we're pretty sure we'll be at the root. And then we can start including arbitrary files. So instead, we want to get the etc password. And so we can just start guessing or start putting in files that we know exist, and we can start including those local files into the web content, into the web page. And so that's why this is called a local file include. We're including files that exist on the system that shouldn't be accessible by the web server, but because we're able to put in these special characters, these ... slashes, we can break this. Okay. So let's see here. So yeah, so we're able to include local files. Now, the local files are interesting because it is the permissions that we're reading files with are the permissions that the files or that the web server is running as. And so if we look at Apache, grab Apache, we see that Apache is running as www data, which is good, right? We actually want that running as www data. It is not uncommon. It's fairly rare on the public internet, but it is not uncommon in my experience for locally developed applications, like applications that are developed by your company and only ever intended to run inside of your company. It's not like a public or like a customer focused application or anything like that. It is not uncommon to see those run as root. Okay, and if those run as root, then you can do something like this. Instead of getting etc password, you can check out etc shadow, and all of the password hashes for that web server would dump out onto the screen. Now, I knew that wasn't going to happen, so I was relatively okay. Also, this is the default Kali password, so you could totally crack my Elite Tour password if you wanted, but this is the way that local file include works. Now, if we run password again, you can see that this is all garbled, right? Like this is awful. I wouldn't want to actually read this. You can view the source, and you'll see somewhere around here, so much code. You'll see it normally. Now, what happens is, the reason for this is that this is the way it comes back. This is the way the actual file reads, right? So in the source, it looks correct. But since the web browser is trying to render HTML and it doesn't see any like BR tags or anything, any tags saying like break those lines up, it just kind of like, you know, regurgitates it onto the screen with no formatting or anything. So if you see something like this, you can just check out the source. Or again, as we see, you know, some of the usefulness of burp come through, we can use burp to check it out too. So. Okay, so that is, I got to start getting ready to go to the movie. I don't think we have enough time to jump into, what else do we actually have? Oh, command injection? We can do command injection real quick. We got a little bit of time. Yeah, let's go over command injection real quick. I kind of did this in my last process stream, but I want to go back and see it working in Mutillidae so I can make sure that I'm ready for it tomorrow. So this is a very common kind of example for command injection. What happens with command injection, at least basic command injection, is that some application will have like a DNS lookup or a ping functionality. So like they'll have like your routers might even have like this uptime checker, like can your router access this site? Right, and it's useful for troubleshooting, like, you know, hey, you're getting weird internet connectivity problems. Can your router actually see that thing that you're trying to access? And so it'll have like a ping or a DNS lookup. What it's actually doing, and I don't think, oh yeah, it's actually hooked up to the internet. What this is actually doing is, you could re-implement DNS in PHP if you want and like have it do all kinds of crazy stuff on the back end. But that sounds awful. So what a lot of developers do is take shortcuts. So instead of like implementing, you know, various functionalities in their whatever web application they're using, they'll just use the binaries on the host application or on the host system, right? So they're actually using something like PHP pass-through or you know, like pass-through or the system function or you know, shell, or there's like a bunch of different ones in PHP because I don't know, man, PHP is a mess. But anyways, there's a bunch of different ones. So we should be able to see, do we have the DNS lookup? Yeah, sweet. So I'll actually look at the DNS lookup. And let's see if we can spot the actual command it's trying to do. All right, here it goes. So this is posting. Let's see. So where is it setting the post? It's probably getting all muddled because of this other code that happens. So what this application will do, and you can see it up here. What this application does is you can actually, and this is another cool thing about Mutillidae, you can actually toggle security. So you see security level 0. That means that there's like no protection at all. And you can actually level up the security a couple different levels to like add in input sanitization and output sanitization and a few other, you know, kind of protections. So there's like a lot of this code in here. And that might be the stuff that's making it more difficult to just easily find the code that I'm looking for. Ah, here we go. So it's using the shell exec function. Okay, so the shell exec function is the thing that's saying, okay, I want you to actually drop down to a shell. I want you to use the nslookup command, and I want you to nslookup whatever they input into the terminal. So just like we did on the SQL injection, we can actually test this actually on the shell itself. So again, what's happening here is no different than what's happening on the shell itself. So you can consider this sort of like the anything that happens in here is actually happening in the shell. So what's happening is that on the shell we do something like this. Okay, so if we do google.com like we did before, we will see that that output that we got here is identical to this output. So all it's doing is taking our input, passing it to the underlying shell, the operating system shell, and then taking the output of that that command and spitting it back to us. Now, there are, and this is getting into Linux or really just command line operating systems in general, but there are these things called command delimiters, okay? And you can actually chain multiple commands together. And we actually saw this earlier when I did the apt like update and apt upgrade or whatever. Like we do this, you know, in Linux a lot without really thinking about what we're doing, what we're actually executing here. So if we do nslookup google.com, we can actually chain another command to it by simply doing a semicolon and then doing ifconfig. And what it does is it executes nslookup google.com and then uses and then runs ifconfig, because this is a command delimiter. All right, it just says do this one, and then once it's done, do the next one, and then once it's done, you could even chain like another one if you wanted. You could like ping c1 google.com, and so it runs your ifconfig or your nslookup, then it runs the ifconfig, and then it'll run the ping. Okay, just over and over and over and over again. So now let's see what happens if we do google.com ifconfig. We actually see the exact same output we got before. And we can do that again. We can do google.com, ifconfig, ping, c1, google.com. And again, we see the exact same output. Now, a word of caution here. If you are messing around with this, first of all, the biggest word of caution at all, and I say this in all of my videos, and it's like all over everything, do not do any of this stuff unless you have permission, right? So we're doing this on a local VM. We're not doing this against a live target out on the internet or anything like that. Okay, this is actually illegal if you do it to anything that you don't have explicit permission to do so. Now, the explicit permission is important because if you're at work and you work in computers, you work in IT, or even if you work in security, or hell, even if you work in offensive security. So I actually run an offensive security team at work. You may think that you have implicit permission. That means that the permission is implied because, you know, it's your job to secure things and it's your job to break things or whatever. This is hacking, okay? This is actually illegal unless you have explicit. Someone has explicitly given you very precise authorization to do this kind of stuff. Unless you have that explicit permission, it is illegal. So do it on local VMs, do it on Hack the Box, do it on things that you have explicit permission to do. Now that I've gotten that out of the way, if you're doing this, remember that unless you put -c and then a number, you are going to ping forever. Okay, if we just ping google.com, it's going to run forever until we stop it. If you do that to this poor web server, it is going to spin up a ping process and it is going to run forever. Okay, and I have definitely not, a friend of mine totally has, but I have definitely not ever spun up like 200 ping processes on a server before during a penetration test. I would never do something like that. Hashtag I totally did something like that. So please, please, please learn from my mistakes. Do not repeat my mistakes. When you do command injection, when you're testing for command injection, use the -C1 google.com, okay, or whatever you're pinging, right? Just do the -C1 so that it just pings once and cancels out. It doesn't actually go on forever and ever and ever and ever. I totally doxed myself. I live in Southern California. Yes, I think everybody knows that. But yeah, so when you're doing command injection, when you're testing for command injection, and you use a ping, which we'll go into why you would use ping in a couple minutes. But when you do a ping, make sure you do the -C1. Now, Windows, I think by default only does 4 pings or 5 pings or something like that. I believe the tag to only do 1 ping is like -N instead of -C. But it's not the end of the world if on Windows you accidentally do the don't put the -N1 or something like that. Anyways, so let's, what are some of the other ways that we can run multiple commands at the same time? Well, we already saw the and, right? So we'll do and ifconfig. Now, what's interesting about and is that you're literally doing anding. Okay, you're literally doing anding. And so what it is talking about here is that anding, like in Boolean logic, where you say something and something, both have to be true. Okay, both have to be true for it to return true. So the same thing kind of works here with like command concatenation, is that you do like nslookup and ifconfig, and if you do nslookup against google.com, that nslookup works. There's no error, and then it runs ifconfig. But if you'll notice down here, we ran nslookup against some random thing. nslookup errored, and ifconfig didn't run. This is the reason that why we do apt update and apt upgrade. What this is saying is that we want to do the apt update, which goes through and updates all of the apt mirrors that we want to use, right? All the different addresses that we need to query and all of that stuff. And if that succeeds, then we want to do apt upgrade. The reason that we do it that way is that if we don't update our mirrors, if this fails for some reason, we don't want to move forward with the upgrade. We want to make sure that we've got the newest and most up-to-date mirrors and all of that stuff. That is why we do apt update and apt upgrade, is we want apt upgrade to not run if this fails. This is important to know when you're doing command injection, because sometimes you might do this. You might do this, and ifconfig doesn't run, and you're like, oh, it must not have command injection. No, that's not the case. It's just you did and on a bogus nslookup address or something like that. Okay, so what you can do instead is we can do or. Okay, now or doesn't care, right? Or means either this or that. Okay, both don't have to be true. Only one has to be true. So just because this one fails, the next one can run. Okay, so you can use or for your command injection as well. Real quick, I want to address something that is in the YouTube chat right now. The YouTube chat is asking, is cross-site scripting illegal? And the answer is yes, unless you have explicit permission to do it. Okay, and cross-site scripting is specifically interesting because if you're doing like persistent cross-site scripting, so where you actually inject it into the content of the website and it's not just a reflected, like a get reflected cross-site scripting, it's very difficult to target who you're targeting. So, and like I said, cross-site scripting actually attacks the browser through the server. So first of all, you have to have explicit permission to attack the server, to inject content into the server. And then you also need explicit permission to attack whatever browser you're attacking. So yes, it is actually illegal unless you have explicit permission. If you don't have that explicit permission, it doesn't matter what your intentions are. Now, things get a little more complicated with bug bounties, but bug bounties as long as they write their scope correctly and all of that stuff, their scope is giving you explicit permission to do very specific things. So pay very close attention to what the bug bounty rules of engagement and scope are and all that stuff. But yes, all hacking is illegal unless you have explicit permission for the targets that you're attacking. Okay? So just wanted to clear that up because this is very important stuff, right? None of the stuff I'm doing is illegal because this is my VM. It's all local. I'm not attacking anything on the internet. But it's very, very important. My entire job, my entire career revolves around the fact that the hacking that I do is ethical and it's with permission and it's requested. Okay. The difference between what I do and criminals do is consent. I mean, like, honestly, and that is a metaphor for a whole bunch of other things as well. But everything I do is with permission. And that is really the only thing that separates me from criminals as far as like hacking is concerned. So make sure you have that permission. Anyways, so you can use OR for your command injection. We've seen a couple different ways, right? So we can use the double bar for OR. We can use the double ampersand for ANDing. And then we can use the semicolons to just, like, you know, run multiple commands. There's a couple other ways that are interesting. And what's important about knowing these multiple ways to do something is sometimes certain things will be filtered, right? Like they might be going, oh, no semicolons or ampersands. Like, we know that's command injection. That's bad. Well, if they're using this deny kind of base security, they have to guess every single way that we can inject commands. So they might like know about the semicolons and the ampersands, but they might not know about the double pipe for OR. Or maybe they know about all three of those, but they don't know about like subshells. So what happens if we do? Let's do this. So we'll go into our Mutillidae. And we do echo google.com into file, or not file, foo. Okay, so if we cat foo, google.com's there. So if we ns lookup cat foo, we actually get the output as if we had ns lookup google.com. Now, what in the actual heck is happening here? I'll show you another way to do this. These are different ways to invoke subshells. Now, what's happening here? The contents of foo is google.com. So we have these things called subshells where we can actually execute commands, and then we can operate on the outputs or the results of those commands. And that's exactly what we're doing here. So what we're saying is we need you to cat the file foo. So just output the file foo and take the result of that and run nslookup through it. Or you can look at it a different way. I want to nslookup the result of cat foo. Okay. And then this is it's just a different syntax to do the same thing. Okay. We want to nslookup the result of cat foo. Now, we'll use this a lot. You'll see this a lot in like other ways. Like if you do, so we can do like a bash for loop where we want to do for I in, and then we'll say like cat foo, where like foo is a file with a billion, a million entries in it or something like that, right? And then we'll do something like nslookup $i. So you'll see like we basically say for oops, mess that up. So what we're going to say is like, so we want you to cat foo, and again, this is like a million different domain names, right? In foo, we want you to cat foo, and for every line in the foo file, we want you to nslookup that next line. Okay, so this is very common for scripting and stuff like that, but we can use it for command injection. Okay, so what happens if we nslookup ID? Okay, so what's going to happen is the same thing that's going to happen, right? We're going to run whatever command's in here, and then we're going to try and run nslookup against it. So if we do this, nslookup is going to error out. Well, someday. It's going to take a while. Oh, looks like Viro 101 is about to take their OSCP. Good luck. Congratulations on getting through the class, and good luck on your test. I'm sure you'll do very well. So what happens is we take the output, and NSLOOKUP will error out, but in the error, we'll get some output. Now, if we run ID, we'll see that ID has spaces in it, so it can kind of mess up and get a little confused and only show us part of it. But if we really need to know what user we're running as, we know multiple ways to get that. We know who am I doesn't have spaces in it. So it'll error out, and it'll basically say, it'll include saying, I don't know who root is, right? It's just it basically substitutes the username for whatever we're looking for. So this is another way that we can get command injection working. Now, I said that we would talk about, and this also works if we just do this, right? It's the same thing. I said that we'd talk about why we would use ping. Now, let's think about an example of, let's say that it doesn't necessarily give you all the output, right? If we put in something here and we put in some nonsense, instead of showing that it couldn't work, it just says, oh, it errored out, please try again. There was an error, right? So how would we know, how would we detect command injection that way? So we can do TCP dump IE0 or loopback, and we want ICMP. Okay, so what we do is we set up a listener on our attack box that listens for traffic. And since we know we're going to use ping, we're going to set TCP dump to only listen for ICMP packets, or else it's going to be noisy, right? We only want to see ping packets come back to us. Like I said, ICMP, or not like I said, but so we're using ping. Ping really is, there's a bunch of different ways to ping, but generally when we talk about the ping command, what it's doing is it's using the ICMP protocol, and it's generating ICMP echo requests and then ICMP echo replies. Yes, 90 and mad, this is live. So we're going to listen to ICMP. We're going to use our command injection. So we're going to say, okay, I don't care about your NSLOOKUP, but I do want to ping C1, and I want to ping myself. Now I'm using the loopback interface, but again, this could be, whatever your attacker IP is. And when we hit that run, again, we're imagining that we don't actually get the output here. When we get that run, we see the ICMP echo request come from our target and go back, and the reply goes back to our target. Okay, so we can actually tell that even if we didn't get output here, we could actually tell that we're getting some sort of command execution on the target, and so we can see that happen. And so that's why we would want to use ping, but as I mentioned, ping on Linux goes forever, so we want to make sure that we minus C1. Now what happens if we don't do that? We get a billion of these coming back at us, and this thing hangs forever, and it might not even hang forever. It might just spawn it off into the background, which means that we just have a ping process that's running forever, which would all be bad. We don't want that. And so we can actually stop this, right? And we can do other things, like we can go back to google.com or whatever. But the the whole web server's hung, so we actually need to AUX grep ping. Some web servers can actually recover from that, like it's multi-threaded, or it'll spawn the ping process off to something else. Doesn't look like Mutillidae, or I don't have Apache set up to do that. So it actually can hang the web server. So again, if you're doing this on an engagement, please use the minus C1 so that it doesn't just go forever and ever and ever and ever. Okay, so that is command injection in a nutshell. We've done, did we hit all of our subjects? So yeah, SQL injection, cross-site scripting, and command injection. We hit all three. So that really is the stream. Yeah, Yeah, so I need to get ready for the movie. 90N Mad in the Twitch channel brought up something interesting that I want to hit on. So they mentioned that that he's been doing pen testing for 7 years, or they've been doing pen testing for 7 years, and we learn even on the base topics. Yes. So I think in the hacking community, we get really caught up with, like this black voodoo magic, like crazy wizard stuff where we're like, living inside of IDA and a debugger and like, dropping ODAs left and right in, like their mics and stuff. And like, that's real hacking. It doesn't matter if it's hacking. It doesn't matter if it's, incident response. It doesn't matter if it's SOC analyst work. It doesn't matter what it is. In security, I think we get so caught up in that wizardry, but the reality is where all of your gains are going to be, where really everything thrives in security, and where like the best incident response, the most mature security companies, is not that wizardry. It is in flawless execution of the basics. And if you haven't had the opportunity to listen to John Strand's rant about flawless execution of the basics, I will see if I can dig it up somewhere on YouTube. I'm not sure if he does it on YouTube, but I know he does it when he teaches classes. But we get obsessed with this concept of like, oh, well, I need to do the OSCP into the OSCE, and then I've got to take their advanced Windows exploitation course and all of this stuff before I can actually be a hacker. But the reality is the best way to prep yourself to be a hacker, like the best way to learn hacking, is to be a developer, to be a DBA, a database administrator, to be a Linux administrator, to be a Windows administrator, to be a help desk person, and just get exposure to all of these technologies and how people operate them. Because if you know how people operate them, you will always know how those systems can be broken. And as cool as like reverse engineering and exploit development really is, the reality is that a lot of what we do, and I'm not preaching to 90N Mad. I hope that 90N Mad doesn't take this as me preaching at them. This is just kind of to my general population, because I know there's a lot of people in my audience that are either new or working on becoming pen testers or working on becoming hackers or whatever. I just want everybody to understand this. Flawless execution of the basics is really where it all comes from. The reason that I can do the stuff that I can do is because I've been a web developer. I was a help desk person and a systems engineer and a Linux administrator for 15, 20 years. I know how these systems are installed. I know how that they work. I know how to troubleshoot them. And because I know that, I can break them easily. And that's what we're all striving to do. So continue to do the wizardry. I'm not saying don't. All of that stuff is fascinating. It's great. I want to learn it. I try and learn it as much as I can. But don't get down on yourself if you don't know it. Don't get caught up in only learning that, or abandoning your fundamentals learning in favor of that wizardry. Learn the fundamentals. That is what will get you far in your career. That is what will get you into systems for your clients. That is the value you will provide for the companies you work for and the clients that hire you. And then all that wizardry stuff, great. Awesome. I love reading about that stuff. Write blogs, make videos, show me that. I want to learn it too. But that's all extra. Okay. That's all extra. So anyways, with that, hopefully everybody had fun today. I know that I got lots of good notes, and I appreciate you guys being with me for my dry run for tomorrow and all that stuff. And I'm off to go see Captain Marvel. So I'm super excited about that. Hope you guys have a great rest of your weekend, and we'll see you soon, hopefully.